Okay, this is the P1 paper from January 2021. It's the last question, question 9, and it's an integration question. We've got two very different styles of integration to do there. Let's jump straight in and get started with it. So part 1 says, can we integrate 3x plus 2 squared, all divided by 4 root x dx. So what we need to understand is that we're going to multiply out the bracket here and end up with a quadratic. We're going to accept the fact that this is 4x to the half. We will divide our quadratic into 3 different terms and then integrate everything. Okay, let's actually have a go at doing that. So all the time we're going through and doing this. I haven't integrated yet. I've got to get it in an integratable form. So leave the integral in the question. Multiplying out 3x plus 2 squared, you can do it yourself as 3x plus 2 times 3x plus 2 and take your time over it. There will be some students in here that can do what I can do, which is to say, if I'm doing a plus b all squared, it's a squared, 2ab and b squared. So that's 9x squared plus 2 lots of 6x, which is 12x, plus 4, all over 4 root x dx, which then works out to be, take my time over this, this is 9x squared over 4x to the half plus 12x over 4x to the half plus 4 over 4x to the half dx. Last step, just to tidy that up then before we start integrating. So I've got 9 over 4, and if we're dividing powers, obviously we're subtracting them. So that's going to be x to the, don't say 1.5, call it 3 over 2, leave it as fractions, improper fractions, plus this is going to be 3, and x divided by x to the half actually leaves us x to the half there. And this is then going to be 1 over x to the half, which is x to the minus half dx. So now I've got it in that format, I can actually go ahead and integrate it. So integrating is adding 1 onto the power and then dividing by the new power. Well, if I divide by 5 over 2, that's going to be the same as timesing by 2 over 5. And this is absolutely a case where I'm not going to divide by 5 over 2. It makes it harder for me. So I'm going to leave it like that. Plus, add 1 onto the power. So dividing by 3 over 2 is the same as timesing by 2/3. I'm going to do it slowly, but if I was doing this on my own, I actually would have just cancelled those out straight away. But let's just take a bit of time over it. And then the next one, adding 1 onto the power makes x to the half. And dividing by a half, I'm not going to do this slowly, is the same as timesing by 2. So it works out to be 2x to the half. Don't forget our constant of integration. That will become important later on probably. And then we just tidy this all up. So tidying this up, that's 9 over 10, x to the 5 over 2. That's 2x to the 3 over 2, 2x to the half, plus c. And there's nothing else actually to do with this one. Just make it nice and clear what these numbers are when we're going through and doing it. But if we look back at that, in its simplest form, x greater than 0 didn't really make any difference to this particular question. And that's a question in its own right. It's quite an interesting part 1. Part 2 is completely separate from part 1. So we're done with part 1. Part 2 then says, we've got the curve y equals fx, and what they've done is they've given us f dash x. Remember, that's the gradient function. It's the differential. So they've given me the gradient function. They've given me f dash x. They're telling me the y-intercept is -8. They're telling me that the point x, y, 3 minus 2 lies on it. And they're telling me the gradient at p is equal to 2. So they've given me enough information to now go through. I'm just going to unpick it all to work out what I'm going to be doing. So first thing to say is that if they've told me that f dash x is equal to ax squared, no it's not, sorry, is equal to x squared plus ax plus b, Then if I integrate that, I'll get fx. So fx is just equal to the integral of x squared plus ax plus b, which gives me, add 1 onto the power, divide by the new power. And this is a lot easier than what we just did a second ago, isn't it? So add 1 onto the power, divide by the new power, put my bx, don't forget my constant there. So I've got fx. So almost go through and say, right, I've used that bit. And now they're going to tell me that the y-intercept is -8. So if the y-intercept is -8, what we can say is at x equals 0, y equals -8, or in other words, f0 equals -8. So f0 equals 0 plus 0 plus 0 plus c. So we get c equals -8. So c is equal to -8 is one of the letters that we managed to work out. So my fx now is x cubed over 3 plus ax squared over 2 plus bx -8, because we've worked out what that bit is. Let's go back and find out another piece of the information. So they've told me here, notice I'm just going down the list here, they've told me here that when x is 3, y is -2, or f3 is -2. Okay, so if f3 is -2, then sticking f in there is going to give me -2. So 3 cubed over 3 plus a 3 squared over 2 plus 3b -8, or -8, all of that works out to be equal to -2. So that's going to be an equation, let's call that 9 plus 9a over 2 plus 3b -8 equals -2. So that's going to give me 9a over 2 plus 3b is equal to 9 minus 8 is 1, so is equal to -3. That's one of my simultaneous equations. It's going to be a simultaneous equation question. They've also told me, the last bit, that the gradient of c at p is equal to 2. So if that's true, I can put that information in. So f dash 3 is equal to 2. So f dash 3, f dash was x squared plus ax plus b. So x squared plus ax, so 3a, plus b is equal to 2. So that's going to give me 3a plus b is equal to -7 here. 2 take away 9 gives me -7. So I've now just got a set of simultaneous equations here. Equation number 1 and equation number 2, and we can just solve these to work out what A and B are. Let's just do that really quickly. If I do number 2 times 3, I'm going to get 9A plus 3B equals -21. I've already got 9A over 2 plus 3B is equal to -3. Let's subtract those from each other. And if I do that, I get 9A over 2. Okay, 9A take away 9A over 2. I get 3B take away 3B. They cancel. And I get -21 take away 3 gives me, I take away -3 gives me -18. That means that A works out to be equal to minus 4 here, minus 36 divided by 9. If that's true, we get 3a plus b is equal to minus 7. So 3 lots of minus 4 plus b equals minus 7. Minus 12 plus b equals minus 7. Gives me b works out to be equal to 5. So my final answer for fx is a third x cubed minus 2x squared plus 5x minus 8. Okay, hopefully that makes sense.